Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and now we are on to the topic two-dimensional random variables. In the previous video, we have seen the two subdivisions of this particular problem, which is f of x comma y. The probability density function of the two-dimensional random variable is given to be xy squared plus x squared by 8, wherein the x ranges from 0 to 2 and y ranges from 0 to 1. Now we will move on to the third subdivision of the given problem. What is our third subdivision? We are asked to find the probability of x less than y. We are just asked to find the probability of x less than y, which is always a double integral, which is minus infinity to infinity f of x comma y dy dx as per the two-dimensional random variable formula. Now here we will just find out the values for or the ranges for x and y. What will be the ranges for x and y? Here, since we have x less than y, we will just take it to be x is equal to y, and therefore when x ranges from 0 to 1, 0 to 2 or 0 to 1, x ranges from 0 to 1. If x starts from 0, y is also equal to 0, and if x starts from y, we will have the upper range to be y here. So x's range will be 0 to y and y's range will be 0 to 1. So this is how we fix the range for the given problem. Since we are given the probability of x less than y, we have to fix the range first and then we can integrate as per the formula given. When x is equal to y, we have the x's range to be 0 to y and y's range to be 0 to 1. So therefore the probability of x less than y is equal to integral 0 to 1 integral 0 to y f of x comma y dx dy. Since we have interchange the change of variable here, since we have the constant definite limits in the range of x. Since we have the constant definite limit in the range of x, we will be interchanging the variable order of integration, which is dx and dy. Usually we will be integrating with respect to y first and later we will be integrating with respect to x, and here we will just interchange the places since we have a constant we have a variable here in place of a constant for the range of x. So on integrating with respect to x, we have x cubed by 3. We have here x cubed by 3 and x squared by x cubed by 3 here and x squared by 2 here. And on applying the limits, we will just apply in place of x y, and we will have y power 4 by 2 plus y cubed by 24, and we have to differentiate it with respect to the variable y. So on integrating it, we will have this is y to the power 5 by 5 and y to the power 4 by 4, and on multiplying it with the denominators existingly, we will have this value as y power 5 by 10, y power 10 by y power 5 by 96. Y power 4 by 96 within the limit 0 to 1, and on applying the limit and just simplifying, we will be having 53 by 480 as the value of the probability of x less than y. So moving on to the final problem, which is the probability of x plus y less than or equal to 1. As we have seen already in the previous classes, if this is the case here, we will just have to fix this equation as the existing term or the key point for us to fix the range of the given integral or the given question. So we will be just taking up the given probability as the equation here, which is x plus y is equal to 1, and in turn we will have the value of x to be 1 minus y. Therefore the x's range will become 0 to 1 minus y and y's range will become 0 to 1. And now we can easily find out the value for probability of x plus y less than or equal to 1. So what is the range of x? Range of x is 0 to 1 minus y and range of y is 0 to 1. So as usually, we will be integrating double integration, integrating with respect to y first and with respect to x first. This is our formula: double integral minus infinity to infinity f of x comma y dy dx, where f of x comma y is the probability density function of the given variable, which is given as xy squared plus x squared by 8 into dx dy, which is equal to integral 0 to 1. And on integrating with respect to x, we have xy squared plus x squared by 2 into y squared plus x cubed by 24. So this will be the value on integrating with respect to x, and on applying the upper limit, we will have in place of x 1 minus y, and on squaring it we will have this term, and on cubing it we will have this term. So this is what we have done here. We have just applied the upper limit for x value alone, and on simplifying it we will have the value of y alone, in this particular line, so that it is easier for us to integrate with respect to the variable y. So on integrating with respect to variable y, as usually we will have 15y cube by 3 plus 25 12y power 5 by 5 minus 25y power 4 by 4 plus y minus 3y squared by 2 within the limit 0 to 1. And on simplifying it, we will be having 13 by 480 as the value for the given probability of x plus y less than or equal to 1. So this is what our two-dimensional random variable problems goes like this, and we will have some more problems in the next video as well. Thank you.